Hello everyone, this is Shin, your TA from IAT167. Starting from this week, we're going to have online tutorials. So here we decided to do live recordings, but please feel free to follow the tutorial page in Canvas if you want to just do it on your own, and we should be able to answer your question via live conferencing softwares. But if you want to have a guidance video, then you can follow me here. So let's start from the base, week 10 lab base. Please go to Canvas and download your base first. Today we're going to work on a video. We are going to work on a platformer, building a platformer game. So in this game, in today's tutorial, we have controls in the players, and also we're going to build a set scrolling feature for your player as well, so that as your player moves, the background changes. Further, we want to make digital mapping so that you can create more complicated platforms for your games, and also place and add in some items that your player can collect. All right, so let's start from our script. So let's check out what we have here. Before we go into the code, let's run your script and see what we have here. Press the run button, and then let me switch to my other window. All right, so now you see what we have here, a very simple platformer game. So we can use keyboard to control the ellipse moving left and right and then jump. However, we cannot restrict this movement. So when it goes out of the screen, it's gone. All right, so let's go back to our code, see what we have here. So in the main script, first we declare a bunch of variables for mouse movement control, and then also we need a gravity so that the player can fall down when it's not in the platform. And then we implemented two methods, key pressed and key released for the keyboard control. Note that we only have three keys here, which is up key for jump, left and right for moving left and right side. In setup, we have the canvas size, and then pay attention here, we actually set the frame rate to be 24 per frame per second. The default value is 60. The reason we set it to be 24 here is that we want to have a slower frame, so when your player jumps, we can have a more bouncy visual effect. And then we initialize the player object with the value. We also set the jumping value of your player to be true. We'll go into here and explain what it does in a moment. And then we add in some blocks. Those are the platforms that you see where players can jump around with two p vector arguments, which is position and dimension, the size. All right, so let's see what in the draw function here. So first, we have a few if statement to judge what are the status of your player. If the up key is pressed and player jump is not true, which means the player is grounded, and then we allow the player to jump. So here, the reason for the second variable player.jumping is that we don't want the player to jump continuously while it's already in the sky. We want to disable the jumping feature when it's jumping. So you cannot do double jumps. So here we set them left and right. If they are true, we move the player, we give it a false. And then we call player.update. Let's see what's an update. So go to character, and then you see update. Basically, it does the same thing as our prior lab tutorial. So we add in dimension, the movement, add velocity to the position, And here we're also damping the speed a little bit, so it not goes so fast. All right, so if player dot block is not now, which means player, let's go to see what block function does. It has block equal to now as the default value, and this stores the value of which blocks the player is currently on. And this is our block class. So if this value is not now, that means our player collide with a certain block. And then if player.block is on, player is false. Let's see what this means. So we'll have is on here. That's jump to George collision using bounding box. So if it's on the block and then we make it jumping to be true, so that will allow the player to jump when it's not in the ground, but also in the blocks. If player jumping is true, and then we give it an up force, move gravity force. So let's see what move method does here. So it basically just add in a force with a p vector variable to be its parameter. And then we go over all the block you have in your array list, from the first one till the end of your blocks. So we need to check if it collide with your player here. That's what check function does. Again, it's a bounding box to check the collision. And if that works, and then we give it a velocity. So player dot velocity dot y is more than 0. And then player dot land on, we set the block inside this land on method. So it stores exactly which block our character is currently on. And otherwise, we know that we call the player.file function. That means we switch the velocity, so it goes it goes down instead of jumping up, and this can be treated as the gravity it has. So after that, we also need to call the blocks and then draw these blocks. And finally, we draw the player. So this is our main script. And also, we have already gone through what in the blocks you have, besides field and constructor, we have is on to detect if the player is on the blocks, if they collide with each other, and draw me. For character method, we have field and then character, and there's move, update as 0, and then jump. It has this up acceleration. Land down to store the block which the player is currently on, and fall if it is falling down, and then draw those. All right, so let's next let's actually implement images for your player, because right now it's just an ellipse. So what we're going to do is let's go to your character class, and then we're going to add in an image here. So let's start from p image, and we call it img, and let's initialize the value in your constructor. Img equal to load image. If you check the data file inside lab week 10, and then there's image called mouse.png there. So let's use that image as our character. All right, after assigning the value, we want to resize it. So let's shrink your image a little bit by calling the resize method. Image.resize. and then 50, 60 file. The original file size is 600 something over 600 by 600, so it's too big. So we resize it proportionally. So let's run your code and then check how it looks like right now. You may find there's nothing changed, right? After run that. So because we haven't changed the Xiaomi here, so let's actually do this. Let's comment out the ellipse, and then we should call the image method. And here, the file name. And if we want that to be the center, we want image width and minus image height. So we place the we move that center. We place the image in its center. And then let's set some parameters. Stroke 0. So it has box that we can see. It's 0 is black. And then no fill. Now we create this rectangle. So it can be more clear that we know the shape of our image. So it's x and y would be minus half the x dimension and half the y dimension. And then this is the length and the width and the length of our picture. All right. We also want the mouse to switch, being able to switch directions. When, for instance, when it's facing right, we want the mouse, when our mouse moves to the right, we want it to face right, or vice versa. So here, we want to have another if statement to judge which direction is moving. So if velocity is less than 0, that means it's moving to the right. Then we scale your image accordingly. So now let's save your script and write and see what's going to happen. So now you should be able to see the screen. Let me pull up mine. All right. So now you can see my mouse is here, and the direction it's facing is also changing. And also there's the bounding box. So let's go back to our script and let's keep going. So we're going to create next another subclass of block for creating cheese blocks that the little mouse can collect those cheese. So start a new tab and let's name it cheese. All right, so this will be an inheritance here, and then class cheese x tens block. And then let's also start with the field. So you should have an image. Let's call it image, and then a parameter, a constructor. Cheese. And then let's put in the parameters. It should also have 2 p vector, one's position, one's dimension here, And then we actually get this from its superclass. And next, let's initialize your image here by load image. If you go to your data file, there's one called cheese1.png. Let's use that one. Again, we need to resize your image because the size again was too big for our canvas. So let's resize it to the dimension that we want to have. So dimension.x, dimension.y. We'll initialize these values. Later in main script, we will create the cheese. However, do a type conversion here, as our image resize only take integers, not float data type. So we should have, again, the draw me feature. Let's have this override method here. First, push matrix. Remember to pop matrix. Let's put it here in the end. And here we should translate to position.x, position.y. So we can draw the image at its center. Again, we need to move the image to half dimension, or half its width and height. So we're done with our cheese class. All right, so if you're done with your cheese class, let's actually run your project and see if there's any errors here. If you're doing all right, we should move forward and create a new tab, which is called game word. So here we're going to use the game word to store the items, the block layout and the cheese layout using a two-dimensional array so that your environment actually maps to a two-dimensional array. Before we start doing the mapping, we should first set up some constants to represent the blocks, the different types of blocks that you have. It can be 3 different status: an empty space, solid blocks, or cheese block. So we're going to use static final int tile empty, and let's make it equal to 0. We already used the final int in our last tutorial. So in the future, whenever you use that, whenever you use 0, it actually equals to the tile underscore empty string. All right, so let's give values to the other two states. The solid block, which equal to 1, and also the cheese block, which equal to 2. So we should next define the size of your blocks, and then this hold value of your different types, the size of your different blocks and cheese. So this would be the field. Also, we should start an array list of block tab and have it equal to, let's initialize it, a new array list. Block. All right, so this is our field. Again, after you're done defining these values here, we should create the digit map. So create the digit map for your level, your game level. This is really important step for building the digit map. Well, as introduced in the lecture video today, it actually used a two-dimensional array, which are pure numbers, numerical numbers, well, more precisely integers, so that each of that specifies the type of platforming element in that position. While later on, based on this map, we'll lay out different tiles or empty spaces of beaches. So let's actually copy the two-dimensional array list from your tutorial page if that's faster, but you can also type it in manually. Now we have this. So as you can see that we have the first element to be our 0, that means it's our space, right? And then this is the last column that we have either solid blocks or the empty spaces, and in between sometimes we have those two, number 2, they are the cheese blocks. So here we should actually redo our game word. Well, before how we implemented that is in setup, we have our blocks added in this way. Now, right now, we should actually comment this out. And then we're going to add in blocks in your game word class. All right, so let's go back to your game word. Well, we should use a nested for loop in your game word to instantiate the constructor. So for int I equal to 0, if I is less than, the array list name is map dot length I plus plus. And then we should use another for loop to go over its second dimension in j equal to 0 if j is less than map dot length map I dot length I j plus plus. And then let's switch that element. We should go over array element in your two-dimensional array, map ij, and see which types of block it is, right? So if it's case, if it's tile solid, and then we should add in block dot add. This is exactly the same as how you would initialize the value before in the setup. So new block, and then new p vector. It takes 2 vector. So we should get its p vectors size of both tile. All right, so the first one, first p vector represents for its position. The second one is its dimension. So here is why we get that. This is its position for the x and y. And then we should multiply them by the tile size. And this is its dimension, okay? So make sure you understand why we use j multiply tile size and I multiply tile size to represent its position. And then we should add in break after we're done. So we do the same for the other two. Well, we don't need to draw anything or add in anything for empty. So let's just do another one for your tile, cheese tile, cheese tile, and then add in this cheese block. So after we're done, we should set default. This means when it is empty space, we actually do nothing here. So it's blank. And then don't forget the semicolon here, do nothing. So finally, we should add in a very long block that covers the bottom of your screen, serves as the ground for your player to move around. You can treat it as the ground. And this should be outside of the for loops, which is your ground. And you won't be able to see that from the player's perspective. New block. And then let's put in its position and dimension. Well, you should think about why is this, right? So for its position, it start for its x is actually all right. And did you figure out why that we put in these parameters here? Because we're going to do side scrolling. Later. So I want an extra long x. So that's 3 times of your canvas size. However, we didn't change its dimension for the height. So it remains the tile size. Therefore, we put this position to be its center. And then that's height minus half of your tile size. This is actual width is for side scrolling, which means your background moves along with the player. All right, so after we're done with the game word constructor, the third thing is to declare the draw me method. Oh, we can also call it override your draw me method. So for your draw me method here, let's go over all the blocks in your array list. Draw them accordingly. In I equal to 0, if I is less than blocks dot size I plus plus. And next block B, the one block B is one of the component, the F components in your block array list, and then we call B draw me. We draw that specific block, right? Well, we may have more than one types. As you can see, we have solid blocks and cheese blocks. So how do we change that? Well, let's actually copy this and do an overloaded draw me method by giving it a tapped parameter, which is your character tab. So C, let's call it C. So for Again, everything else remains the same. Right now, it has a problem. The function draw_me doesn't expect any parameters because our block doesn't have that here yet. So we actually should, copy, I'll start overload it here as well. Draw_me with character row. And that should solve our game word arrow here. All right, so now we're done. We should actually test and see how it goes. However, we haven't declared a game word yet, so let's actually do that first. So after the array list, let's do game word, let's call it GW. And also go to setup and initialize the game word. Make it equal to a new game word. All right, so let's see. Let's save your script. Okay, so let's actually save your code and see what will happen. Well, I assume nothing will happen. The game word doesn't appear here yet because this draw_me, new draw_me method hasn't been defined yet, so there's nothing being drawn. Well, let's actually fill that in for your block. So let's give it a stroke, the same stroke. Stroke, and then fill the color, and then push matrix while translate. Pay attention, this time we actually translated using the characters X position, so you should minus that, plus the current position. And then draw it, this remains the same, right? So we finish this draw_me method for your block. And in your main script, we should call is draw_me method, game word.draw_me method, and also we should draw your player. So actually new character, right? Your player here. And everything else here remains the same. We didn't change anything yet. All right, so let's try it this time and see what's going on. So now you can see that the tiles are all here. However, it has some problems of showing the cheese images. And also my mouse actually falls from the top to the bottom. So let's fix that problem. What's going on? Well, did you figure out why the player didn't land? Well, it's really because we are using the blocks here. However, in the main script, the script still thinks we use the blocks that we declared here. So we should actually take this out. So it actually touches on the game word classes blocks array list. So let's comment this out. And then let's go over your code. Well, by this time, you should already commented out all the blocks that you have added before manually, and adding this initialization for your game word GW and call it draw_me player method. And then you should see that we have these red lines here representing our problem. So GW, because it's the game words blocks array list, right? So we should go over the array list there. And this time, we already called the draw me method of your game word. So let's take this second for loop out, comment it out. So this time, let's run your code again, and then you should be able to see your little mouth collide with everything. Okay, let's run it. Let me switch my screen. All right, so now is what your code looks like. Now the little mouse not only collide with cheese, but also the blocks, it collides with everything. So we should also fix that. So that your mouse only collide with the blocks, the solid blocks, but these small things are cheese, right? Let's go back to your script. So this time, let's go to your cheese script, and where it has this bump method or collision detection method, apparently there is none. Okay, so let's override. For block, there's the check and is on method, but for cheese there is nothing. So let's actually refine the bump method in your cheese class. And we should also give it a tapped parameter called character C. And then we're using the bounding box approach. So here is where you and this should be a Boolean tab to detect collision between the player, any character, and which is your character, right? The player and cheese box. So here is the bounding box detection. If they collide, remove this. We should remove the cheese and return true, otherwise return false. And then we should and then after you're done with adding in this Boolean bump method, let's go to character and see the method called lab10. So this defines what to do when the little mouse or player is landing on any blocks. So we should add in if B is an instance of cheese. So this tells us if B is one of cheese or not, if that's that data type or not. Then we set jumping to be true and return. Let's move it down here. Otherwise, jump to be false. That means if it collides with the cheese, it actually can still jump. But if not cheese, just regular blocks, then we turn it back to false. See where it landed on. All right, so let's actually run our script and then see what's going on this time. So let me go back to my other screen. Let me switch my screen. So now you should see that your little mouse actually went down, and our player moves, the camera follows. And then now it collide with the blocks, but not the cheeses. Again, the cheese should be removed, right? But it doesn't happen. And also we have problems that the little mouse, it can jump, but it then doesn't fall down to the first floor, to the ground. Okay, so let's see what are the problems. Let's go back to your script. All right, so let's keep moving forward. So when you run our code, right now you see that there is no cheese. There is no cheese image, but just purple blocks. So let's try to fix that. So here in our cheese, we have already a Xiaomi feature where we put that. However, when we call it Xiaomi player, when we call it, there is a parameter inside. Gamer.Xiaomi, and then it goes to here, right? Xiaomi player, we actually call this function. And then for each block, we call block.Xiaomi that specified character. Therefore, in cheese, we should overload this method. Well, let's actually copy this and overload that with new parameter character C. So when this method is being called in your main script, and it goes to here with a tabbed character, and it goes to here. And then we should also change our translated positions, counting for C here for its X. And now let's run our script again and see if our cheese appears this time. All right, so now we see our cheese here. However, there's still some bugs that the collision between our little mouse and the blocks are not correctly done, and also the cheese, it doesn't disappear, right? So we should let's fix this. So let's go back to your character script, and then let's check the method we have here. So for I've added in this for our update method. We need to check when the player goes off the longest blocks to let it land on the floor. All right. So in our character script, in our block script, there's a method called check here. So let's actually change the method name to bump because we use it later in the cheese method and we overloaded it this way. So in the blocks bump method, we should also consider the okay, so in our block method, after we change the name from check to bump, let's go to our main script. I should also change this to bump. And then we should update this position for the bounding box change from this to position x minus c dot the characters dot position dot x, and we do the same thing. And we only need to do it for x but not for y because it's moving horizontally and there's no changes happening vertically. Before we moving into next, I think the white background isn't very beautiful. Also, as guided in the instruction, let's change your background to this color. All right. All right. So after checking my code, I found that the block in my block I don't have a bump method. It's actually called check before. So let's change it to bump here. And then we should also change what you have here in your if method accordingly to bump. And also I don't like the white background, so let's change the background color to any other color you like. And now because our block superclass has this bump method, and also we should change it x position of its center to the new one because we don't need to change y because the character only moves left and right. For up down, it's just jumping. So let's keep it the same way. And then if you see the bump method in cheese, we actually overrided the method by adding in get more dot remove blocks, and this time when the little mouse collide with the cheese, it should be removed. All right, so let's run the code and see what's going on and if the code is working. Okay, so now that my little cheese, my little mouse moves. However, oh, it also collide. Let me see if it's collide with the cheese. Okay, so we're going to jump higher and then they'll collide. So there's a little glitch here. As you can see that my little mouse not stays on the surface of these blocks, but it's in the center of the blocks. So there's something wrong. So let's go back to our code and fix it. All right, after checking our code, I found that I forgot to put in the values here, or somehow it got removed. So I should add in the dimension spike. And then when you run the code this time, there should be no problem about the little mouse. So it's on the surface this time. Also, do remember to give setting this argument here to player.fall because here for your file player, we actually added in this parameter block B, so that we assign a new position for the Y, which added in your blocks dimension and the characters dimension. So when it falls, it stays on the top of your surfaces. All right, let's run your program for one last time and see how this looks like. Let me switch my screen. Now you can see right now the little ball stays on top of your screen, and then it can goes to left, right, jumps, and then it collides with the cheese. I've also changed my background color so it looks better. And then this is the top. And also our little mouse is doing side scrolling with the mouse movement. All right, so now let's see what is our challenge today. So again, first, because this lab tutorial is online, and then you should submit your lab challenge online as well for grading purposes. Your challenge is to add in a countdown timer, which set a time limit so that the player wins the game. If the player wins the game, she can finish collecting all the cheese pieces before the time runs out. Otherwise, she'll lose. So this is condition. Also, you need to display HUD, head up display, so that it shows both the timer and also the cheeses that have been created. For instance, if there's 60 cheeses in total, and you have collected 23, and then you display the score there. For total, although currently we have 60, but you may want to do it in a programming way, not hard-coded it in. There's also a bonus challenge if you want to add in this following feature. So if the feature is that the player will need to gradually slow down for its movement, for its moving and jumping with more cheese collected, so that will decrease its speed once it's collected more cheese. While there's however, some power-up objects can boost up the time remaining. So we provided you a heart PNG in the data file inside the same folder, so that you can use that as your power-up. All right, guys, this is all of our lab tutorial today, and I hope you enjoyed it. Please let Ashu and me know if there is any questions. In the meantime, we'll stay online to answer any of your questions. Good luck with the challenge. See you next week.